All right, so dividing polynomials is what we're on to today. So our objectives are to divide a polynomial by a monomial. We kind of talked about that a little bit in that last problem, recognizing the difference between those. Dividing polynomials using a long division algorithm, like you're in 4th grade again, only with polynomials, so it's kind of twisted. And dividing a polynomial by a binomial of the form x minus a using synthetic division. Okay, so we're learning 3 different things today. Like I said, I don't think we'll finish this lesson up today, and that is okay. We'll have some extra time to work on it. So first step, to divide a polynomial by a monomial. All right, so let's look here first. This is a polynomial. Why is it a polynomial? It has addition in it, okay? So the addition separates each monomial. This is a monomial, a monomial, a monomial, okay? And so we combine them with the addition signs. That makes it a trinomial, okay? Then we are dividing that, it says, right? Divide a polynomial by a monomial. We just have the d, so we just have 1. All right, another way to look at this is to say it's the same thing as the quantity a plus b plus c times 1 over d. That may be helpful for you to think about. Well, it's not the reciprocal, it's just pulling the d out. It's saying it's 1 over d, right? Because there's no d up here. So it's not the reciprocal. Or the other way you can think about it, okay, is that the d belongs to every part of this. We have to do a times d, we have to do b times d, and we have to do c times d, which is what we're showing here. We are going to divide, but we have to understand this first in order to divide, because fractions are division. Oh, I'm sorry, thank you. My bad. Okay, so a divided by d plus b divided by d and c divided by d. Yes, thank you. I wondered why you were saying like you thought we were doing division. I was like, we are. So, yes. Okay, so now that we have that underway, how are we going to do example 1? Okay, but so like here is our first mono of the polynomial. Over 3xyz. Okay. So then I'm going to have a plus sign, and then I'm going to write my next set. Okay, so Josh, not that one. You did that one. Ethan, do the next one. So what's our, oh, are you writing the first one down first? Okay. Yep. Good. All right, and then Brandon, the last one. So I'm going to have minus, okay, x to the 4th. You got it. Okay, perfect. Now that we have it set up, we can cancel.
So you can just pull the...
Okay. So now it's time to simplify or do the division. We simplify like terms. So 3 divided by 3, these just cancel, right? Then I have x squared divided by x. It will leave me with just x in the numerator. Do we understand that? Because x squared is the same thing as x times x over x. So one of my x's cancels, and it just leaves me with 1 in the numerator. Okay, so I'm going to cross out the 1 here, and I'm going to change my 2 to a 1. Or cross it out and just leave the x. How about my y cubed divided by y squared? Okay, so yes, it cancels this y, cancels one of those out and changes it to 2. This is a z. That's a z. That's all right, it's a little tricky. So let's go ahead and write this one simplified. So the 3's are gone. We have an x and a y squared divided by a z. Maybe if I make my z's like that.
It's just the z looked a little higher.
You're okay.
So
I understand. All right, Ethan, I want you to reduce yours. The 9 changes. Good. Bottom x goes away. 5 changes to a 4. Good. Then I have yz squared and yz in the denominator. Both y's go away. Okay. All right, so what is that going to be? Over nothing. Okay, so we don't even have to write the 1, so I can erase that fraction line. Nice. Okay. Then, Brandon, your turn to simplify yours. Okay. Mm. Okay, walk us through that. How did you just get that? Okay, so this is going to be x to the third. Okay. The y's cancel out. Okay, and we're left with 4 z's up there instead. Okay, we keep everything where it's at. So it's going to be, you said minus, what was it?
minus x to the third
Z to the fourth over 3. Perfect. All right. That is it.
You don't add or subtract it.
You have simplified it as much as you can because you have gotten out all the like terms. You divided each part like you did the division and divided each part. So this is as simplified as each one gets. It looks uglier actually, right? Then
You take the 3x to the fourth z and subtract the x cubed z to the fourth and then just put that over 3 and simplify it further.
you cannot. We don't have common denominators to subtract them.
Just do the numerator and still just put it over 3.
Can't just do the numerator and put it over 3
It's like, so like in the,
to make it a 9.
so I mean, in the quadratic formula,
Uh-huh.
we have all this stuff that we're doing above a 2.
But all those things are numbers.
Yeah,
Like we replace b squared in the quadratic, we replace b with the b value. And then we have all the numbers.
Yeah, but I mean, what I'm saying is we're subtracting and adding stuff up here and just leaving it over 2.
Uh-huh.
Can we not do that here? Because we have, in the numerators of both, we have like terms, so can we not extend the whole thing to be over 3, subtract what's on top, and put it over 3?
But in the numerator, we actually don't have any like terms because this term is xy squared. This one is x to the fourth z.
Just in the last two.
But we don't have like terms. This is x cubed times z to the fourth. Those are not like terms because they're different. The only time we can add like terms is when we have the same exact term. So like 3x squared plus y minus 4x squared. Okay, in this case, this term is like this term because they both have x squared.
Okay, so we can't take the x to the 4th minus x to the 3rd
No.
and make it just x.
We cannot because they're being multiplied together. So they're not like terms unless they're identical.
I thought you could.
Okay. So yeah, so in this case, we cannot go, right now we cannot go any further with that.
Okay.
That is it. Okay. Good work though. Simplifying that, or dividing that polynomial by a monomial. Awesome job. Okay, so then let's look at some division. Okay, to divide a polynomial by another polynomial. So this is when we don't have the monomial. Okay, we're going to use the long division algorithm that you have used to divide large numbers. It's going to look weird, promise, but it's going to be the same thing that you've done. So a remainder of 0, okay, so if we get 0, indicates the divisor and the quotient are factors. Okay, because sometimes the question is going to say, is this a factor? And you have to do the division and see if it has a remainder of 0. Okay, because some of our answers are not going to have a remainder of 0. Okay, all right. So in example 2, if we jump right in, it says divide x to the power of 3 plus 4x squared plus x minus 6. We're dividing that by x squared plus x minus 2. Yikes! It's weird looking. It's not so bad. Okay, so we're going to set it up just like, we're going to rewrite the problem using your long division format. The key here is to be sure your terms are always in descending order. So I have x cubed, x squared, x, and no x, right? So 3, 2, 1, 0 are my exponents. All right, so that's what I'm going to do. They're in order, so I'm ready to go. So I'm going to write x cubed plus 4x squared plus x minus 6 divided by x squared plus x minus 2. Yeah, old school division.
I hate old school division.
You're going to love it even more after today.
No, I'm not.
Yeah, man. It's going to be awesome.
Why do we have to line it up like that?
Because it's division.
Well, can we, let me write it up the way I was thinking.
This is the one problem like new math where they teach you like 4 different ways to do long division. They don't work in this case. You have to know the old school long division algorithm.
So like this, lining up the pairs. Why does that not work?
Well, let me show you why this works, and then we can have the conversation why that does not work. So you can leave that, and we can look at it. All right. So this says we're going to divide the first term of the dividend. Okay, so first term of the dividend by the first term of the divisor and write the result. Okay, so when we're looking at this, we're not looking at the whole thing. We're just looking at this first term. Okay? And just the first term of the other one to start with. Yes. Okay, let me pause here for just a second so I can answer Lauren. So, back in business. So what am I going to multiply x squared by to get x cubed? X. Exactly. So this is x. That's the number I put up there. Now I take this.
Oh, you're not multiplying them, you just say what you need to do.
Okay. What do I have to multiply x squared by to get x cubed? X. X squared times x is x cubed. And now I'm going to say, well, x times x is a positive, what's x times x is x squared. Negative 2 times x is negative 2x. All right? And remember, I am subtracting all of this. So I'm going to subtract each of those, and then I will bring down the negative 6. Where did I get x squared? Okay, so this term, I have to figure out, because I'm only looking at the first term. So what do I multiply x squared by to get this first term, x cubed? Well, x squared is x times x. I need a third one, so I multiply it by x. And that's equivalent to x cubed. So then for the next one, I have x times x. That's x squared. And for the last term, I have negative 2 times x, which is negative 2x. That's where I start. Like I have to pick that. The first two is where I start because I want it to always, I'm trying to get rid of this, right? Just like in division. The x that I picked by these numbers out here.
So she takes the first one on the left.
So multiplying x squared by x by x, and then negative 2 by x.
Yes. So it's really, I'm taking, so x squared plus x minus 2. And I said, okay, if I multiply this by x, I can get, like it's distributing. I can put the x in the front, but x squared times x is x cubed, which is what I wanted to get here, so they would cancel. And then x times x is x squared. X times negative 2 is negative 2x. So this goes right there.
Why?
Because I'm dividing. That's how you do division. And I have to distribute. Whatever number I put up here, I have to distribute to the whole polynomial. And then I can cancel, right? X cubed minus x cubed is 0, or you could say it cancels. 4x squared minus x squared, no, is 3x squared.
What?
Yeah, makes sense.
Yeah, 4 minus 1, right? It is, we just don't ever write it. It's understood because they're like terms. I'm saying I have 4x's squared. I'm taking away an x squared.
Because you're subtracting, so the x squared doesn't go away.
No, the x squareds don't go away. I'm not dividing, I'm subtracting. Right. So this is,
X squared from x squared.
no, it says 4x squared means I have x squared plus x squared plus x squared plus x squared. If I subtract an x squared, I get rid of one of them, which leaves me with 3, which is 3x's squared. Okay, and so then for the next one, so we have a positive 3x squared. We have x minus a negative. Well, that's the same thing as a plus. So x plus 2x is 3x. Because I'm subtracting the whole thing. Then I have to bring down my negative 6. All right. Okay, that's going to be, yep, a problem. So now with the second one, okay, so we looked at this first term and this first term. Well, now we have a new first term. So what do we multiply x squared by to get 3x squared? 3, a positive 3, right? Okay, so now I'm going to multiply this whole thing by a positive 3. So 3 times x squared is 3x squared. 3 times x is a positive 3x. 3 times negative 2 is negative 6. And we're subtracting all of these again. Okay? So 3x squared minus 3x is canceled. 3x minus 3x cancels. Negative 6 minus negative 6. Remember, minus a negative is the same as plus. So negative 6 plus 6 gives us 0. So the question, we were supposed to divide. So this is this is it. I'm going to pause you for just a second. So x minus 3 is a factor. But plus 3, pardon me, thank you. X plus 3 is a factor. But here's the cool thing too. Now we know that x squared plus x minus 2 times x plus 3, right? Like that, we got a trinomial times a binomial will equal the polynomial in the center. So let me adjust your homework a little bit, because you're not going to do 1 through 33 there by any means.